So good morning, everyone. Welcome to this webinar from the European Water Association on ways to zero CO2 neutrality. We'll start shortly. We are still letting few people in. So we'll start in 1-2 minutes. So 1 more minute and then we're good to go. So I think we'll start now. So good morning, everyone. My name is Arthur Gische, Water Policy Officer for the European Water Association. And a huge welcome to you and participants, and as well as our speakers for being here today for our webinar on ways to zero CO2 neutrality. We will also like to thank our sponsors, Xylem and Bentley, that allowed us to have three events today. So Xylem is a leading global water technology company committed to solving critical water and infrastructure challenges with innovation. They provide water technologies and solutions across the whole water circle for utilities, industries, and buildings. And Bentley's mission is to provide innovative application and services for the enterprise and professionals who design, build, and operate the world's infrastructures, advancing both the global economy and the environment for improved quality of life. Bentley's had helped water utilities, government, and engineering firms around the world to demonstrate excellences and cutting-edge digital advancement in water, wastewater, and stormwater infrastructure. And we are also really glad at the EWA to count both of them as our members. Before we move to the first presentation, I will quickly share my screen and would like to, in a few minutes, to just present you what the European Water Association is doing in a nutshell. So, the European Water Association is an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries, and we have several types of members. We have national members, corporate members, and as well as sponsors and research members. And our role or aim is to provide a forum for the discussion of key technical and policy issues in Europe. We organize several webinars as today, conferences, workshop, meetings, publication, and are active on social medias. For today's webinar, we will kindly ask you to use the chat box in order to make more general comments and to use the Q&A function to drop your question, and if possible, to indicate the speaker to who the question is addressed to. We cannot use the raise hand function, so please stick to the chat and Q&A. After today's webinars, you will receive a link with the presentation, and this webinar is being recorded and will be shared next week on our YouTube channels. Thank you. So now I will stop sharing my screen, and we will move to the first speakers and the first keynote speakers. Our first keynote is Ries van Preussen from the Waterboard R and MAS in the Netherlands. And since 2021, Ries, you are project initiator, energy and climate neutral, and are site as Waterboard R and MAS in the Netherlands. Your talk today will focus on greenhouse gas reduction target development and technical solution. And I understand that you focus also, that you have an internal consultancy and project development for sustainable energy production and mitigation of greenhouse gas emission. Ries, the floor is yours. Please share your screen.
Yes, thank you, Arthur. Welcome, everyone. So as Arthur already kindly introduced, I am Ries van Preussen from the Waterboard MAS in the Netherlands. And to put that a bit in perspective for everyone, the Waterboard in the Netherlands is a very old governmental organization. We have our own elections. We date back, to the very first beginnings of waterboards or type of organizations that were dealing with water in the Netherlands that date back to the 11th century already. There is about 21 waterboards in the Netherlands, and we are unified in the Uni of Waterboards, so to say. So that represents us at the national level and also deals with some of our interests on European and international level. So that gives you a bit of a broader picture of where we are, what we are. So about greenhouse gas reduction target development, already in 2010, our government initiated a so-called climate agreement, in which, in this case, all the waterboards committed themselves to certain climate goals, energy reduction goals at the time. And to monitor this, so to say, we developed the climate monitor for the waterboards. That is a sort of coherent set of data that is collected across all the waterboards in the same way in order to be able to distinguish and compare. And that gives a very nice picture of what we are doing, what we are achieving as waterboards already for some time back now. Then in 2019, so a little before the previous climate agreement ended, we entered into a new national climate agreement where not only the waterboards, but also a lot of sectors like health, education, industry, committed themselves to similar goals and sort of outlined what they wanted and could achieve in order to prevent climate change, basically. So we already had this climate monitor. New ambitions were set in this 2090 agreement. And then in 2023, quite recent, we had the Green Deal in Europe that even sharpened some of the ambitions that were already set. And actually also the ambitions that we set in our national climate agreement sort of were updated accordingly. So that gives us the current state of ambitions, I would say. We want to achieve 100% energy neutrality in 2025. So that's coming really close. We're actually doing a good job, in particular as AMA's. We were last year at 86%. And this year we have 2 big solar parks coming online that will actually bring us approximately to 95 this year, I guess. And there is a lot of biogas that we are going to produce extra. We're currently developing that project that will put us probably over the 100%. So 2025 is a reachable goal. And we're actually well on our way to achieve that. Climate neutrality, we have a different set of ambitions. Previously, we had 49% in 2030 as like first milestone to achieve, and that was recently updated to 55% in 2030, which is in line with what the Green Deal suggests. And then there is 100% climate neutrality in 2035. That is also an updated ambition. Previously, it was 100% in 2050, but 2035 is now the new goal. So we're sort of raising the bar. And I think this is a very interesting ambition that we will come back on later in this presentation. Furthermore, we want to become fully circular as a water board. So all the resources that we use should be reusable or reused in the first place. And to achieve 100% circularity, we set 2050 as our goal. So on climate neutrality, we report.
Just a quick second. Yeah, we don't see your screen with the presentation. Do you want me to share it for you, or do you want to do it directly?
You don't?
No, we don't. We see
that
you.
Is...
Yeah, perfect.
I had to press one more button. Excuse me. So this is what you missed. All right. So on climate neutrality, we report our greenhouse gas emissions according to the Greenhouse Gas Protocol, and we divide that in three different scopes. I think most of you might be familiar with the definition of these scopes. If not, I'll walk you through. So starting at the bottom, scope 3 is basically all the climate greenhouse gas emissions associated with any goods that you buy, any services provided to you by third parties. And this is a scope that we not yet fully report on. It's notoriously hard to get all the emissions that are associated to third-party services. So this is one that we try to report on, but since we're not complete on that scope, we don't focus too much on it yet in our reporting. That is different for scope 2 and 1. Scope 2 is all the emissions called indirect emissions that are associated to consumption of electricity, basically, or other utility energies that you use. And these are actually quite comprehensive in a sense. We, as Waterboard AMA's, reduced these emissions of CO2 almost to zero, simply by buying 100% green and sustainable energy. So that leaves mostly Scope 1 emissions to focus on right now. These are the direct emissions from all the primary processes that you do in your business. Well, in our business as a waterboard, this is primarily cleaning the water. We are responsible for wastewater treatment in our, let's say, area. And then if we look at the Netherlands, there is about 350, a little over 350 wastewater treatment plants, and they all operate more or less on the same principle. So let's have a brief look at a typical wastewater treatment plant. It treats the effluent, screens all the big parts out of it, all the sand and grit that will sink to the bottom there. Then you might have a primary clarifier, gives you primary sludge. But the most important part of basically any wastewater treatment plant in the Netherlands is the active sludge tank, where we provide air to feed our bacteria that do the cleaning of our wastewater. Here we break down all the pollutants and clean the water basically. That sludge is separated out in a secondary clarifier to give us our effluent. The sludge is processed in a different way, depends a little bit from plant to plant, but it typically has like a sludge digester to produce some biogas, and whatever remains from the biogas production will be incinerated in an incineration plant. The fact that we have this as a typical wastewater treatment is a problem or a challenge. So what's wrong? Well, in the active sludge tank, that is where all the cleaning is done basically. We have a lot of biology to remove both all the nitrogen pollution, all the phosphate pollution, and basically most of the carbon pollutions. These are converted to either nitrogen or CO2 basically, but they have a couple of byproducts. There is some methane emission and there is some laughing gas emission, so N2O. And these are very strong greenhouse gases, besides, of course, all the carbon dioxide that is emitted. For methane, depends a little what number you use, but I think we use 28 times CO2, and for laughing gas, it's approximately 300. So these are very strong greenhouse gases. And then we said in our ambition, if we want to be climate neutral, we want to be 100% in 2050. It's here. It should be updated to 2035. But how do you become 100% climate neutral? For energy neutral, it's you produce as much energy as you consume, then you're energy neutral. But for climate neutral, it's a little bit different, because you can reduce quite a lot, and then you get to 80% or 50% or 55% climate neutral. But if you go to 100% climate neutral, it basically means that you have to reduce all your emissions to zero. There is a small escape if you want to allow for compensation measurements, but in principle, you should reduce to zero. And where I believe that we can optimize the current wastewater treatment plants to minimize the emissions, I have a hard time believing that we can reduce the emissions to zero. And it actually shows in our climate monitor that these emissions of methane and laughing gas are our very biggest problem. So I showed here AMA's. In light is the laughing gas, and let's say the middle color reddish, brownish, I don't know, is the methane emission. And for all the waterboards, the picture is more or less the same. These are the biggest contributions to greenhouse gas emissions that we have. And they're a direct consequence of the way how we treat our wastewater. So that's one thing, our climate ambition. But if you look back from, let's say, a little bit more holistic point of view, there is a couple more things that are wrong with our current wastewater treatment system. The first is what I like to call the energy paradox. In the influent, we have a lot of pollutions, but these represent a huge amount of chemical energy. There has been a report in the Netherlands that analyzed this and said there is like 16 petajoule of energy, chemical energy in the wastewater that we treat in the Netherlands. From this 16 petajoule potential energy, basically, 8 petajoules gets directly lost in the aeration tank just by consumption, biology, emissions of CO2, etc. So that's a huge loss, and that doesn't incorporate all the energy that we have to put in to get rid, basically, of these pollutions. We put a lot of energy in aeration. It's our biggest energy consumer, 3 petajoules, basically. So what happens here is that we consume energy to get rid of sustainable energy. And that is, for me, a very fundamental problem, basically, for the current wastewater treatment systems. So where does all the other energy go? Well, a little bit is lost in the transportation system. A small part, 2.4 petajoules, gets converted to biogas from our sludge treatment. A large part gets incinerated in the end, and a minor part, 1.6 petajoules, is released back in the effluent, so is basically not treated by our system at all. There's a bit cleaner picture, and to give you a feeling of how big this energy potential is, 16 petajoules. 1 petajoule corresponds to 23,000 something barrels of oil. So it's significant. And what I think should happen is that we get not only this 2.4 petajoules in green to convert to biogas, for example, but a much larger part. We'll come back to that later. So the second problem, and that relates a little bit to the previous problem, but I like to call it the nitrogen paradox. There is a similar imbalance where we put a lot of energy in removal of nitrogen from our wastewater, which we do for very good reasons, but we convert valuable chemical forms of nitrogen, organic nitrogen, ammonium, nitrates, into a chemically not so interesting form of nitrogen, N2, which is basically 80% of the air around us, and a very stable molecule that barely interacts with anything, basically. Where on the other hand, we use a huge amount of energy to convert this N2 from the air back into all kinds of chemical fertilizer, mainly ammonium and nitrates. And the amount of energy associated with that, at least in the Netherlands, is 2 billion cubic meter of natural gas. So that accounts to 5% of the total gas consumption in the Netherlands. And I think worldwide, it is a very similar number. It's between 2% and 5% of total energy consumption in the world that goes to the production of fertilizer, nitrogen fertilizer mainly. And here we put in, again, this 3 petajoules of aeration energy, but also a large part of the 8 petajoules of chemical energy that were present in the sludge into just the breakdown of these molecules. And that is a total waste and not circular at all, in my view. Then there's more. We increase our effluent qualities, where we focused primarily, let's say in the past, on nitrogen and phosphate removal. There is an increasing list of other pollutants that we should remove or want to remove at least. To name a few, there is all sorts of pharmaceuticals, there is microplastics, there is PFAS, and I think the list continues, and there will be other types of chemicals on there that are simply not removed by our treatment plant, at least not at the moment. So what we're doing is we are looking to build additional steps of treatment behind this current step in order to meet the effluent requirements and to remove these additional focused pollutants. But by adding all these steps, you might wonder at some point, we can get a third, a fourth, a fifth step, maybe even in the end. At what point would it be more efficient to completely redesign your system? This is the last one, I think, that we are adding to our ambitions, and that is water reuse. I think in the Netherlands we are relatively okay, but we suffered also a couple of years with extreme droughts, and that really focused our attention also to the reuse of our effluent, where currently we are discharging our effluent basically to surface water, rivers, maybe to the North Sea. There is an increased interest in reusing the effluent in higher standard water systems. So either for agriculture or maybe industry use, or ultimately even as drinking water, potable water. So I think all these, let's say, problems with our current wastewater treatment system, lead us to a set of requirements what a future wastewater treatment system should look like, or at least should achieve, in order to be able to get to our ambitions. And climate and greenhouse gas reduction ambition is basically just one of them. But since we want to go to 100% climate neutral, it can be a very demanding one, urging us to start developing such a system at least. To my knowledge, such a system currently doesn't exist. at least not at reasonable cost, reasonable energy consumption at sufficient TRL level. So what it should look like. I put in a big black box because, I currently don't know. There is, I think, a whole set of techniques available that might fit into such a treatment system. Very fundamental, I think it boils down to physical chemical separation of all pollutants. And that can be in 1, 2, 3, or 4 steps, whatever. And it should give us our phosphate salts, our nitrogen fertilizer, basically, and all the carbons as intact as possible, representing the chemical energy in our wastewater. What we do with the carbons later is a bit of a secondary question, I think. At the moment, we use them basically to produce biogas. And as long as we consume natural gas, I think that is a very, very valid and useful purpose for these carbons. Ultimately, you might think of a world where we don't consume any natural gas anymore. And then you might want to think about putting those carbons maybe in a more permanent form that can be stored, at least that are not emitted. So you can break down this one black box into, let's say, more black boxes. A first step that does the main screening, maybe it has some centrifugation or flotation, any technique basically that separates out some of the solids can be useful. Might want to follow up with a technique that filters to a significant small pore ratio to get all other pollutants out that you need to get out. And then there is basically always one pollutant remaining, which is the nitrogen pollutant. That needs a special treatment, either with ion exchange or stripping, or maybe even go back to some form of biological uptake. I don't know. The one thing that I do know is that you want to treat this system as a whole. So we have our influent, and we have whatever effluent quality we want to achieve. Let's say ultimately drinking water. You need to optimize these steps according to what you want to achieve. And that can have implications on what you use in either step. So I think there's a lot of research still needed. There is a lot of research going on in that direction. There is a lot of projects where, let's say, individual steps that I just outlined are being tested. But I think what is lacking is a place where the entire technique treatment train, is evaluated, updated, improved continuously. And I think that is what we need in order to have already in the coming years the option to install wastewater treatment plants according to the ambitions that we have set ourselves for the coming years. So yeah, in order to do this, I would say if you have good ideas, the best technology providers, best minds, please come forward. I'm trying to put together a project with the water boards to offer a location where we can put this train together. It's very preliminary, but I think it's good to discuss ideas and options. So I'm very much looking forward to hear if you have any. Thank you very much.
Thank you very much. One couple of questions on the Q&A. We'll come back to this later. I think now we will move to the next speakers, and as our next presenter will be Elena Wisnar-Malinowska from the European Commission. Elena Wisnar-Malinowska is currently the head of the Climate Adaptation and Resilience Unit in DG Climate Action of the European Commission, leading on a new strategy for climate adaptation 2021 and the Horizon Europe mission on adaptation. She was also responsible for the European Climate Pact as a new major citizen engagement on climate action, and she has worked for now 18 years in the European Commission in different positions, and she will today talk about the 2040 climate EU target and the water sector. I understood that your time is really, really precious today, Elena. So please, the floor is yours.
Thank you very much to all. And I think the time of everyone is very precious. And I would like to appreciate very much the very insightful presentation I could listen to already. So I will bring you from something that is very practical to, again, to a more sort of policy settings level. And thank you very much to organizers for allowing me and inviting me to speak. So I have two hats today. I'm the head of the Adaptation and Resilience to Climate Change Unit, where we are quite familiar with water issues. So it's let's say something we deal on a daily basis. But today I was invited to talk about 2040 and water sector, something that pushed me into some sort of thinking and reflection as to where we are on mitigation and water. So to start with, some facts is that water and carbon cycles are interrelated. And so does water and energy efficiency, right? The scientific basis makes a clear link between the two. But this has yet to permeate better into our policies, legislation, and solutions. We just heard about the Dutch urban wastewater treatment, where the solutions, according to the state-of-the-art climate neutrality, are not yet available. We have considered for too long water and energy as abundant resources, but we are now really hitting the hot limits. So for the big picture, the European Environment Agency estimates that water stress already affects 20% of European territory and 30% of European population, while the economic damage can be up to 9 billion euro annually, with additional unquantified damage to ecosystems and their services. So water scarcity does not affect anymore just the water sector, but also other interconnected sectors like agriculture, energy, fluvial transport, and industry. And we start seeing, competition between the different uses, and some media even talk about water wars. Water availability will be even more pressing problem with the increased climate change and the duration and intensity of water scarcity that we see already affecting European South. And if you want to know what is the future in case we don't act, then better to look there. Of course, mitigation options are also affected by the availability of water. In 2022, for example, we have seen drought that reduced the availability of hydro and nuclear power in a time of high energy prices, contributing to a greater shift towards coal generation. Water is also essential for nature-based solutions, rewetting of peatlands, more sustainable agricultural practices, are critical for climate neutrality. And of course, water will be probing for the effectiveness of these solutions in absorbing CO2. There are already tools and initiatives to make the water sector take pioneering options, what they want for lower emissions. Let me mention a couple of them. The climate mitigation taxonomy includes the criteria for water sector and defines how to make a substantial contribution to climate mitigation. The EU funding sets the obligation of climate proofing of infrastructure, meaning that bigger water infrastructure should undergo both the vulnerability and climate risk assessment, as well as present the best mitigation option based on a carbon shadow price. And this practice should preferably be picked up also by the private sector. And finally, let me mention also research and in investments in innovation. It has been mentioned also by Mr. Van Preussen. The Horizon Europe funding already offers opportunities for that in adopting innovative, long-lasting, and climate-proof solutions. And there, our mission on adaptation is trying to make some demos, demonstration projects in regions, exactly in sectors that affect agriculture or water as critical sectors. Now on 2040, I need to do a disclaimer, of course, because we are still in the process of preparing the impact assessment and the policy statement. So we are not yet there officially. So I need to read carefully. But what I can tell you is that we are working on the impact assessment that will assess options for an intermediate climate target for 2040 on the way for climate neutrality, and it will underpin a communication to be issued next year. If you've heard if you listened to the hearings that happened last week, both Executive Vice President for Green Deal, Mr. Šefčovič, and the Commissioner Hoekstra have stated the intention to propose a 2040 target of at least 90% during their confirmation hearings in the Environment Committee in the Parliament. And this is consistent with the advice of the European Scientific Board on Climate Change. This work is definitely critical, not only as a legal requirement under the European climate law, but also perhaps because it will lay foundations for a new policy framework post 2030. And we know that certain policies or certain measures will already show hard limits in where you can squeeze additional emissions, and more other pieces of legislation like the waste management or the water management will be pertinent in that perspective. Of course, defining the point and the pathway to climate neutrality is important for you as economic agents, as businesses, but also for households, because we need to start making the right investment decisions in order not to lead to any sort of stranded assets. What we look at in our assessment is, of course, the environmental implications at large, the industrial challenge that is out there. You've listened to the previous presentation about, what is the challenge on the technology side. I'm not fully a tech optimist, but I always hear around me that the technology never betrayed us when it comes to climate policy. So let's see whether this will apply also to the other sectors. Of course, the implication for agriculture. My pre-speaker also mentioned the water reuse regulation. Unfortunately, what we see is that many member states are opting out of this, as if the water supply would be, too abundant. So this option is not taken up by largely by all member states. And of course, we need to see the need for investment, the cost effectiveness, and socially just transition. The water part is looked at in terms of climate impact and future availability and importance, for instance, for agriculture, industry, and the land use change and forestry sector. Now, when it comes to wastewater treatment, that requires a lot of energy. You probably know that last year the Commission has issued a proposal that is now being discussed between the Parliament and the Council. And there are quite some provisions that are important for climate mitigation, such as Article 6 on secondary treatment, Article 7 on tertiary treatment, Article 11 on energy neutrality of urban wastewater, Article 20 on sludge, and of course, Article 21 on monitoring. So what does this mean? Let me just unpack this slightly legalistic introduction. Both secondary and tertiary treatment are mitigation measures that do address greenhouse gas emissions. So secondary treatment removes the organic matter from wastewater and reduces methane, and tertiary treatment can help reduce nitrous oxide emissions by controlling nutrient levels. But again, I hear that so far the state of the art or the current state of affairs is such as there is not a full efficiency in that. So with energy neutrality, the sector can link indeed power generation to mitigation, and urban wastewater can use sludge as a source of methane as part of the sludge management to produce biogas, not necessarily to incinerate. So this importance of this piece of legislation, which is probably the cornerstone of water management when it comes to water technologies, will definitely increase in the future. And I hope there will be new state-of-the-art technological solutions that will come on the stream. Thank you very much for your attention.
Thank you very much, Elena, for your speech. Can you just quickly please remind me, till when can you stay with us? Till 11, right?
Yes.
Or a bit later. So I would just make just a quick call for all of our participants. Please use the Q&A if you have any questions for Mrs. Wisna Malinowska. Otherwise, we will quickly move to the next presentation. Okay, so far I don't see any question from you, Elena. Yeah. So, okay. Alexi, can you hear me? Do you want to go?
Yes,
yes,
absolutely.
okay.
I can hear you fine.
So,
do you hear me okay?
Yeah, we hear you okay. I think you should be able to switch on. You had your camera on already. Perfect. So Alexi de Cavorge joined Xylem in 2011, and you are today the lead of the client sustainability for the European UK region. Prior to that position, you had a multiple global and regional management role at Xylem in process engineering, business strategy, and vertical marketing. With a pure play background in the water sector, you are passionate about engaging executive, decision, and policy makers and serving as an advisory in water and wastewater management. And today you wanted to make a remark from the industry, experience and expertise showing on making progress toward greenhouse gas reduction. And I think maybe bouncing a bit on what was just said. So please, the floor is yours.
Thank you very much. Can you see me and can you see my screen?
So the screen is being shared. Yeah, we can see it, not yet in presentation mode. And I just pin your video. We are good to go.
Excellent. So thank you very much, Arthur, for the introductions, and what a great introductions from our two keynote speakers today. So thank you very much. And it's a great segue to this remark that we have now, where we would like to make a connections of like what's possible from the private sector to support this impressive journey that is ongoing in the water sector. So my name is Alexis de Kerkhove. I lead client sustainability at Xylem. Xylem is a global technology supplier serving water utilities, industrial water users, and building services. And what I'd like to address quickly, or in here you have my email address, so feel free to take a snapshot or a screenshot so that you can reach out to me afterwards if you have questions. What we are trying to address here, and I flag a little bit of a few numbers on the screen just in case you were not aware, but there is a huge untapped potential across the entire water sectors, and especially when we look at water and wastewater services across Europe. 1.6% of European 2021 energy consumption goes to water and wastewater services. That is 180 billion kilowatt per year. And just to put that in perspective, it's about 12% of the annual energy use in commercial and public services overall. What is even more impressive is that the greenhouse gas emissions from the same sector, water and wastewater services, are 2.8% of the European emissions. And when I looked at that number, I realized that it was actually a quarter of the annual emissions of the electricity, gas, steam, and air conditioning supply. So when you understand in perspective that you have the water and wastewater sector services, and then the entire electricity, gas, steam, and air conditioning sector, the water sector is equivalent to a quarter of the energy sector, electricity sector, which is, to me, was really an impressive number, which is 176 million tons of CO2 annually. And then I had fun looking at water in general. And I looked at how much wastewater in 2017 was reported by the European Environmental Agency in terms of water, the amount of water being treated by biological treatments with full nitrogen and phosphorus removal. And that is equivalent to 40,000 hectometer cube per year. If you're not familiar with hectometer cube, that is 1 million meter cube. So we're talking here about 40,000 million meter cube per year are being treated with nitrogen phosphorus removal. And surprisingly enough, that is equivalent volume to 42% of the overall European utilizations in agriculture, forestry, and fishing sector. So if we were dreaming in ability to apply water reuse across Europe, we could cover close to half of the need in water utilizations for agriculture, which is very impressive in perspectives, I thought. The European setup is fantastically well built so that we can make progress towards one of the biggest challenges that we're facing, the climate crisis. So 2030 Fit for 55, you're aware of it. Right now, the European Commission is defining the European climate target for 2040, and we aim at targeting net zero carbon neutrality by 2050. So overall, Europe as an assembly of governments is really building up for that. And when we look at the water sector, water and wastewater services to be specific, we see a group of transformative directives and regulations that move in similar directions as the overall carbon neutrality perspectives. First, I will start with 2022 drinking water directives on the left of the screen here, building on regulating on water losses. So with a strong requirements to track and assess water losses within the network in order to address them and reduce them based on an action plan. If I move down on the screen, we look at industrial efficiency directive that has been revised and aim at having an annual reductions in energy from the public, from the utility sector by 1.9%, which is an overall target, which is very admirable. And that's a target annually that needs to be met by the utilities. You're all aware of the great development, the new development of the Urban Wastewater Treatment Directive. Everybody is hanging on the outcomes there. We look forward to 2024 to see the final proposal. Currently, it looks at having energy neutrality for the wastewater treatment plant with monitoring of greenhouse gas emission. We obviously hope to make sure that this new directive builds strong momentum on the climate crisis from the water sector. And then finally, in 2020, you see the new treatment standards for reuse regulations in agricultural irrigation. So again, a lot of transformation from the legislation point of view, more to come, obviously, but there are lots of connections between the two. Gijs gave us a really interesting perspectives from the Water Board in the Netherlands, and thank you very much. So I will not need to go in details on this greenhouse gas emission mapping from a water and wastewater service perspective. In few words, we see that scope 1 and scope 2 are a very majority of the overall greenhouse gas emissions on the plant. The numbers that are here on the screen are indicative. They're not like to be taken as industry average, but more guidances. On the scope 1 process gas emission, as Gijs was highlighting it, are leading those emissions. On the water utility segment, so for drinking water, we are aware that when the water is resourced from the groundwater, chemical transformations of that groundwater release methane and CO2, which are also accounted as process gas emissions. So just for everyone, let's not forget that on the drinking water side, there are process gas emissions also to be considered. On the value chain, Gijs was also highlighting, it's very difficult to track, but there are lots of big categories that need to be addressed first, like the productions of chemicals that are being used in treatment, or also embedded carbon into the infrastructure. I'd like to give you a quick view of what it looks like from a Xylem perspective. Xylem, as I said, is a global manufacturer of equipment and solutions. And when you look at our greenhouse gas emission balance or scope, let's say, we have scope 1 and scope 2 that are the fuel and electricity used in the manufacturing of a product. And that is about less than 2% of our overall emissions. 98% of our emissions at Xylem are from the use of energy, electricity notably, from the operations of sold products and solutions at customer sites. So you see how critical it is to stay very connected to our value chain so that we can help influence and support an overall decarbonizations across scopes, because if our scope 1 and scope 2 contribute to our customers' scope 3, the scope 1 and 2 of our clients, and notably here, the water and wastewater services, are the main leading contributors to reduce our scope 3. So based on this, I'd like to highlight the fact that technologies are existing today at the asset level. We know that there are extremely efficient systems that can build up or reduce energy uses across the water cycle. In this case, we're talking about wastewater collections and transport. Don't forget that you can also address on-site energy generation. We're talking a lot about heat recovery. We're talking a lot about methane and biogas generations. Let's not forget the untapped potential of hydropower, especially in water and wastewater services, where we have a lot of geographic variations in heights across the infrastructure that can be that carry dynamic or kinetic energy from the water that can be recovered through turbines. Very important to address district metering area and eliminate water losses. water losses are about 10% of the overall energy, emissions created through drinking water distributions and treatment. So it needs to be addressed with district meeting area, but also condition assessments of the infrastructure overall. And then finally, move on with digital transformations. I think that another partner and peer in the sector will go in depth on what digital solutions are able to do, but machine learning of existing infrastructure can really help moving forward with reductions of current energy use, but also future development or current developments enables also mitigations of process gas emissions as well. So if I need to close up this short interventions on the topic, we need to take action, not as an individual stakeholders or private sector, but as a group of water people who aim at moving or transforming the sector. The private sector, as I showed, is very committed. We have different drivers, including the fact that we have very pressing shareholders to the companies. But we want to make sure that has its ripple effect across the value chain. Some EU members and water utilities lead the way globally on the net journey, and GACE was the demonstration of that in the keynote speaker. But and as I said, a lot of solutions exist today to make an immediate dent into emissions. Of course, we're targeting 2030, 2035 for net zero, and at the speed at which digital solutions are coming up, I'm very confident that the target can be met, but it requires more. It requires the water sector to be included into the 2040 climate targets. That's very important so that we can all set up a playing field across Europe for addressing that. And government needs to unlock transformational funds. We're not talking about development fund for new infrastructure. We're talking about transformations that can truly support what was presented from the Water Board of AN Mass to close the circularity, recover energy, and address net zero. So we need that momentum to be built. So on that, I would like to close and thank you very much for your attention. And it's back to you, Arthur.
Thank you very much, Alexi, for the really good presentation. I think everyone felt the energy and commitment you have on that topic. I would like to move to the next presenter, Slavko Velitkov. You are Advancement Director, Water Industry at Bentley System. You heads up a team of professionals that delivers Bentley's digital water twin solution globally. And you also further develop new markets and business opportunity with channel partners and added value reseller. And today your presentation will be from gray to green, pioneering carbon reduction in the water industry. Slavko, the floor is yours.
Arthur, thank you very much. And I would like to thank, of course, the previous speakers as well. So hi, Selena and Alexis, very nice presentations and also giving the scope of today's webinar. So from policies towards legislation and towards solutions. My presentation will be focused on more digital solutions, how we can use digital solutions to turn the water infrastructure from gray to green. Obviously, the water infrastructure is boring, as we can imagine, so potable water supply, wastewater collection and treatment facilities, etc. So in terms of the net to zero and the race of net to zero, digital solutions can play an important role. First, a little bit about our company, and I'm representing Bentley Systems. Obviously, we are a global software engineering company, technology provider, which is focused on infrastructure engineering. So planning, designing, building, but also operation and maintenance of the world infrastructure, including water and wastewater. We are an Nasdaq-listed company, and of course, we are fully committed to the sustainable development goals because of course, pressing shareholders, but also our commitment in order to develop a sustainable infrastructure. By sustaining the infrastructure, which is the interface between the people and the planet, obviously, we are sustaining the economy, and we should sustain our environment as well. So in terms of the pressing challenges, many of the previous speakers addressed those. My focus today will be how we can use the digital solutions to address some of the key pressing problems and need to improve efficiency, for example, for our existing systems, but also designing and building new water and wastewater infrastructure systems. Definitely there is a need for investment, and EU policy guidelines and legislation together with the budgets will definitely stimulate local governments, national governments, but also European member states in order to invest in water and wastewater infrastructure. We are facing also a lot of staff turnover. Just in the Netherlands, for example, many people are retiring from the water boards, from the water utilities companies, and this knowledge is lost. So how we can capture that knowledge in order to improve the operation and maintenance of the water infrastructure? Obviously, water is touching many of the sustainable development goals. Out of 17, 6 or 7 sustainable development goals are linked to water and sanitation services. Regulatory pressures, we see a lot of, Alexis also mentioned a couple of directives, and also Elena mentioned those which are there. One of the directives, I would say it's a little bit older as well. So the Urban Wastewater Directive, Urban Wastewater Treatment Directive, dates back from 1991, needs a revision in order to include, obviously, new technologies and new solutions, how we can tackle the wastewater treatment facilities in Europe and improve efficiency. Rising costs, especially on the energy. And what I want to mention is technology and innovation should be fostered and stimulated in order to come up with the new solutions. In terms of solutions and how digital technologies can challenge or can provide support in order to improve efficiency, Alexis also mentioned a reduce of non-revenue water collects, fix the plugs. In many European countries, take Italy, for example, we have non-revenue water on a scale of 40 to 50%. So we are spending a lot of energy in treatment facilities, a lot of water, a lot of treatment processes as well for water which is lost throughout the networks. So there should be more emphasis on fix the leaks and fix the infrastructure, obviously, by assessment of the current infrastructure, of the current network infrastructure and the current facilities in order to improve them. Improve energy efficiency. By improving energy efficiency in terms of pumping energy efficiency and the processes in both water treatment plants and the wastewater treatment plants, we can indirectly improve the carbon footprint. Many of the utilities on their strategic targets have put 2050, for example, to become carbon neutral. In the Netherlands, we have quite aggressive goals for the water utilities. 2025, for example, I'll be talking about case study. So definitely improving the energy use and energy efficiency is key to path to climate neutrality and net zero. Reducing service interruptions, because obviously the water utilities companies are having a lot of stuff which are driving around in order to provide to us, safe and reliable water services, but also collection of the wastewater services as well. So by reducing service interruption, we implicitly also reduce the carbon footprint and unnecessary costs which are there. Reduce operational costs is one of the where digital technology can also accelerate basically efficiencies. So reducing operational cost in terms of assessment of the current asset performance, which pipes needs a replacement, which pipes needs to be changed, for example, where to build new infrastructure, where to build a bluefield or a greenfield wastewater infrastructure is very important. And that is tightly linked to improve capital investment and planning decisions as well. So in terms of the new technologies, I'm pleased to report that Bentley released a new carbon assessment tool, which is a tool which can be used for embodied carbon impact calculations, for example, for water, wastewater treatment plants, but also pipes which are buried in the ground. So what is the carbon captured basically at this point in time? And also this tool can be used for new designs, new optioneering, as we call it. So evaluating options, how we can develop new water or wastewater infrastructure and make it climate neutral. So in this point in time, it's only calculating carbon, but we're expanding this technology and tool to drive basically the digitalization in the water utilities. I would like to mention one case studies where these digital technologies were applied because the time is limited. I picked up again the Netherlands. So we heard today that the Netherlands is leading the way in water management and leading the way probably in the climate neutrality. So Evidis is the second largest water utility here, serving the wider area of Rotterdam Metro. And Evidis recently launched an important project in order to reduce the carbon footprint. They want to become a carbon neutral till 2025, which is 2-3 years to go. And for that, they have a lot of a policy, but also a lot of projects, I would say proof of concept and a real scale projects in order to find solutions how we can reduce the energy efficiency, for example, in this case. So reducing the carbon footprint through reducing of energy efficiency, improving of energy efficiency was key here. So by implementing a digital twin with a real-time data and a real-time, for example, optimization technologies with machine learning, AI, etc., Evidis was able only for one area. This is the water treatment facility in Kralingen, together with a large pumping stations, which is supplying water to the Kralingen area in Rotterdam. They achieved of cost saving around a 33% on the energy. This is around 300,000 K, for example, annually on energy only. If you turn that into a carbon footprint, it is around 142 tons per year only for this site. So extrapolating this digital twin to the complete 2.2 million served in Rotterdam and the wider area, you can see the effect which can make with the implementation of digital twin technology and smarter management of the existing water infrastructure is basically a key here. And in order to conclude my short presentation, I would definitely, my call for actions here, we need to make water a political priority at EU level. So some of the MEPs are also putting forward some proposal for EU a blue deal. We have the EU Green Deal, obviously, but EU blue deal, that water should be make also central in the political level of EU priorities. Second is, of course, digital technology, foster digitalization in all infrastructure related policy making, but also all mega projects which are happening in the EU. 27 countries, and take a holistic, forward-looking approach to the infrastructure. So not only water, potable water and wastewater, like we were hearing today, but take into account more the energy, which is there, take into account agricultural as well. So this nexus, this triangle between the water, energy, and agriculture is key while making a policy and also developing new digital technologies as well. So I want to thank you for the opportunity to speak at this event. If you want more information, you can reach out to me. We have EU Director, Policy Director Bernardo, who is on the call. And also if you'd like to reach a little bit and find out more case studies, how digital technologies can help, reach out to NEDA as well. So thank you very much. Back to you, Arthur.
Thank you very much, Slavko, for the presentation. Indeed, all the participants will then receive all the presentations. They will all have your email address in the presentation. Our next speakers, Daniel Reich. You are based in Switzerland. Since 2020, you have been in charge of the Werdersley wastewater treatment plant, which is the largest wastewater treatment plant in Switzerland, and you are deputy head of the entire production and technology division of ERZ, Entsorgung and Recycling Zurich. And today you will talk about the waste to zero at ERZ. Daniel, the floor is yours.
So, thank you, Arthur, for the introduction, and thank you also the previous speakers for their interesting presentations, and good morning from Switzerland. In the next few minutes, I will gladly give you a little insight into where we stand in the direction of net zero outside of the EU. I had to say that. But first, who are we? ERZ is the means disposal and recycling Zurich. ERZ is a service provider of the city of Zurich. It is responsible for waste and wastewater. Our business fields are divided into 6 areas, as you see here on the slide. In my presentation, I will only focus on the wastewater treatment part with some more information about the waste part. This slide shows a rough drawing of the Werdersley wastewater treatment plant. The wastewater in Zurich is treated in 5 stages. We start with the mechanical treatment. We have a biological treatment here with phosphate precipitation and then a filtration. And since 2018, the wastewater has been ozonated to remove the micropollutants like pharmaceuticals. This allows us to achieve a complete nitrification. We have about 80% denitrification, over 94% elimination of phosphates, and thanks to the ozonation, extensive removal of micropollutants. This diagram shows, let's say, the energy flows on our plant and shows it in a very maybe abstract way, maybe concrete. The wastewater treatment, as you heard before, is energy intensive. We get most of our electricity from the municipal energy supplier, but we have also some solar heat. No, not solar heat. We have solar power, and we cover the peak demand with combined heat and power plants. We produce the heat by ourselves with a big sludge incineration. We have to incinerate we have to burn the sludge in Switzerland. We are not allowed to take it out. And so we have a lot of heat, plenty of heat, and we produce sewage gas, we produce biogas by our sludge treatment. If we would like, we could electrify the gas, and then we would make the plant practically self-sufficient in terms of energy. But since we produce even more heat, we decided to purify the gas and feed it into the municipal gas supply. Here are some numbers about the energy consumption and the energy production on our plant. We use about 46 gigawatt hours of the thermal energy. We have a total electricity consumption from about 29 gigawatt hours per year, and we produce about 57 gigawatt hours sewage gas per year. So how is now the path Zurich is taking to the climate neutrality? The diagram shows it schematically. The goal is the city wants to become climate neutral by 2040, which means that the direct greenhouse emissions here are to be reduced to net zero by 2040. The city always has. The city also has defined the target for the indirect greenhouse gas emissions per inhabitant. These are to be reduced by 30% to 2030, to 2040 compared to 1990. Now, what role plays wastewater in reducing the direct CO2 emission? On the one hand, we are trying to reduce CO2 emissions by using, you heard it before, fossil-free electricity. Zurich has the advantage that a very high proportion of its energy supplied is based on hydropower. We are already use only fossil-free electricity for the wastewater treatment. However, we also like to use the heat produced at the sewage treatment plant and the heat available in the wastewater for heating, for fossil-free heating purposes. I will briefly show a project in cooperation with the electricity supplier of the city of Zurich. On the other hand, we want to recover CO2, make the so-called and needed negative emissions to reach the net zero point in 2030. This means to capture carbon and to store carbon. To this end, we have started a project to bind the CO2 produced by our incineration and store it permanently. This sludge is of biogenic origin and is therefore considered as renewable, climate-neutral fuel. The plant emits about 22,000 tons of CO2 per year into the environment. Capturing this CO2 from the flue gas can achieve a CO2 sink. These negative emissions are 100% chargeable to the city's CO2 balance. The feasibility of such a plant at the Werthölzli site is given, but the energy use of such a plant is very high. The electricity demand is approximately 1 megawatt, the heat demand 4 to 5 megawatts. For the transport and for the storage of the CO2, we put out to tender this spring. I'm not allowed to say what's the conclusion there, but it's planned to store it in a geological repository. The project is also a test for a CCS plant for the Zurich waste incineration, where we have about 400 tons of CO2 we could collect and store it annually. So in conclusion, I will show you I would like to talk about fossil-free heating from a wastewater plant and give you a small insight into the energy network Altstetten and Höng, which is already built in a part. Altstetten and Höng are two quarters of the city of Zurich next to the sewage treatment plant. This energy network is the largest of its kind in Switzerland, and it also shows how a huge supply area can make the switch to renewable energy sources within a few years. How does it work? Here is a simple diagram. There are two heat supplies. The first is some of the exhaust heat from the sludge incineration, and the second one is the heat you have in the treated wastewater. The heat mostly from this treated wastewater is fed into a voluminous energy network, and then heat pumps in the district generate heat for the households, and in summer also cooling for the households and for the industry. In the final phase of this heating, the heating demand per year will be about 172 gigawatt hours, so much more than we produce with our incineration. There will be local heating for about 30,000 households. This is about a third of the households in Zurich, and which saves about 30,000 tons of CO2 per year. So that was a very brief insight how Zurich wants to master this very, let's say, Herculean task of achieving net zero, or at least what we can do on the wastewater side to contribute it. I hope it has inspired you a little bit in the practical way, and thank you. And back to Arthur.
Thank you very much, Daniel, for your presentation and the example provided. We will now move to the last presentation from today. Will be the last keynote from Amanda Lake. Amanda Lake is head of carbon and circular economy with Jacob, based in Edinburgh in Scotland. She's a process engineer with over 20 years of experience in the sector, and her quest is to support water sector utilities, regulators, and practitioners to take rapid climate action, in particular in the area of process emission of nitrous oxide and methane. And she will talk today about climate mitigation in the water sector. Amanda, the floor is yours.
Thank you very much. Can you see my screen okay?
No, I don't see it, and
okay.
You are just back.
That's okay. Sorry.
Yeah.
And apologies for being
yeah, okay, now we can see your screen. We just cannot see you on a camera. It's black, but at least we can see the screen. So
okay.
Yeah.
And can you see the right screen now or the wrong screen?
No, click on display setting, please.
Yeah.
Yeah, on top.
Yeah.
Yeah, here. Do it just to the.
Yeah, it's
you right, left from where you are in the middle, display setting, and then you just click on the arrow below.
Yeah, no, it's hidden.
Yeah,
sorry.
Perfect.
Yeah. All right. So
Perfect.
you can
Now
see
we're
the
good.
screen, but not me. Is that
yeah,
correct?
The screen, but not you.
Okay.
So please, the floor is yours.
Okay. try to put my video on again, but I don't know why that hasn't worked. So I'm very sorry about that. It looks as though it's on. Great. So thanks very much for the opportunity to speak today. And apologies, I was a little later than intended. But from what I have heard, it's been a really fantastic array of speakers. And I would like to contribute a little bit, in particular around mitigation in the water sector. So my name's Amanda Lake, and I lead our carbon and circular economy work within Jacobs in our Water Europe business. I'm a process engineer, and I've had around 22 years experience in the water sector. Primarily in the UK. I'm based in Edinburgh in Scotland, but I'm originally from Australia, which is where I started out in the water sector. And that's where this photo is from. I think on the right-hand side, it makes me feel a bit like home here, where we don't have a whole lot of water. But yeah, we see this everywhere now, and really this is linked to the urgent action we need to take. So I will start, hopefully not cover too much ground that's been covered already, but I'll skip through. I'm sure we've talked already about scope 1, 2, and 3 emissions. I just wanted to share this. This is a recent publication that I've helped support from the International Water Association Climate Smart Utilities Group. And what we really tried to do is replicate the greenhouse gas protocol diagram, which really shows our climate warming greenhouse gases up the top there, and then the specific scope 1, 2, and 3 emissions, which are really relevant in particular for water resource recovery facilities, but also, of course, we can we consider also drinking water facilities too. This publication was specifically around used water or wastewater. So in particular, we see these direct emissions, specifically nitrous oxide and methane, and I'll talk a little bit more about these, but I'm sure we've covered this today already. We can think about refrigerants in those direct emissions as well, and the way we're managing our doing on-site management of sludge residuals and biogas methane as well. And then if we move scope 2 indirect emissions, which we're rapidly decarbonising, particularly in Europe, which is fantastic, these emissions from electricity and energy use. And then we move on to scope 3, so we can think about upstream and downstream scope 3 emissions that could include things like the way we're using water, the way we're managing our sludge residuals downstream, the way we're treating stormwater, the way we are actually purchasing goods with water in, the way we're using water in other sectors as well. So we could be very broad if we wanted to here, but the challenge right now is we're not doing a great job of considering these scope 3 emissions, but there's plenty of opportunity there. So I guess if we're thinking about where the water sector is on the starting line, and I know Alexi mentioned this figure as well, around 1.9%. I think this is for Scotland, where I'm based, but we find that similar figures when we look elsewhere in I guess high-income countries, where we see that we sit within the waste sector. So most of our scope 1 emissions, all of our scope 1 emissions fall into, well, our scope 1 emissions of nitrous oxide and methane, which are really key, fall into these waste sector emissions, which we report at national inventory level. And so we can see all of the countries' reports actually as they've been uploaded very recently. And when we look at this figure, we might think, well, that's incredibly small. You know, why are we bothering? We're not doing much. We're not contributing much. But of course, we all need to get to net zero. We all need to drastically reduce emissions. And as I'll mention, when you think a bit more broadly beyond just our wastewater treatment assets, there is so much opportunity to indeed support the reduction of emissions in other sectors, as we've also heard today. So this is where we sit. And I guess when we think, what is our game plan? So this is typically we're just considering scope 1 and 2 emissions in greenhouse gas accounting to date. We need to be going well beyond that, and Alexi gave a good example of doing that, and I'll also provide some others in terms of water utilities. But when we think about our emissions, this is an example from Anglian Water, who are one of our UK water utilities. And what we can see as we move towards, in this case, net zero in scope 1 and 2 emissions by 2030, that purple bar of process emissions of nitrous oxide and methane really gets more significant because we've decarbonised our electricity use. So we've got green power, and a lot of those residual emissions are these process emissions, as well as some fuel and transport. So the significance of these emissions is really there. And a big problem is these figures are underestimating the emissions of nitrous oxide and methane. So a key challenge is that we're not really starting where we thought. So actually, our global wastewater sector emissions of nitrous oxide and methane are likely significantly higher than are currently being accounted for. And here's just 2 examples from 2 utilities in the UK, again, Anglian Water, but also Severn Trent, where they've rebaselined their scope 1 and 2 emissions, and in particular those scope 1 emissions. When, for example, Anglian Water adopts the IPCC emission factor for nitrous oxide, they find they've got 60% more residual emissions at 2030 than they had from their current method of accounting for these emissions, which is greatly underestimating nitrous oxide. And we see this many places we see this widely. And right now, the IPCC guidelines, which are being used by countries, the 2006 ones, and actually they don't include any requirement to consider nitrous oxide from wastewater treatment because we didn't think it was that significant at the time, but we now know that it is. And I guess the opportunity for us as professionals is to properly account for these emissions. But yeah, in this race, our starting point is not really where we thought it was. So this is a challenge. And so I won't go into this. I know this has been covered already, but of course, when we think about these, our greenhouse gas emissions specifically from, in this case, the majority of our emissions are from the wastewater side as opposed to the drinking water side, particularly as we decarbonise our electricity supplies. But we can think about the emissions that are being accounted for, even if underestimated, things like the treatment nitrous oxide and treatment methane and our sludge line methane and our, to a degree, our effluent, our receiving water nitrous oxide. But then in the red boxes there's emissions that we really aren't yet even trying to account for. So effluent methane, effluent nitrous oxide, that's dissolved in plant effluents, including from CSO effluents, and also sewer methane, which we know could contribute in some work in the Netherlands, 25% of a facility footprint, with the remaining 75% of the emissions being from the treatment plant and the sludge line itself. So sewer and CSO emissions are significant as well. But the good news is that these emissions, which constitute the largest portion of our footprints when we're thinking about mitigation, really can be easily addressed in many cases. And so when we think about methane, we can actually fix the leaks. Beyond, it's great to have to be reusing biogas and upgrading biogas to biomethane and the associated heat recovery that is possible. But if we're leaking somewhere in the order of, if we're leaking greater than 10 to 15% of methane, which some really great work in Denmark has shown, then it negates the impact of producing that green gas to start with, and it's worse than simply using natural or fossil. It's not natural, it's destroying our planet, fossil gas. So the good news is we can very easily stop methane leaks. Some solutions such as covering tanks or improved extraction, vacuum extraction, for example, changing the way we manage our digestion facilities. There's lots of opportunities. Some are more onerous than others, but they are absolutely possible. So that's extremely good news. A key starting point is to start actually measuring these emissions, because until we really measure them, we don't really understand the magnitude of what we're leaking, and that really helps prioritize action and really brings focus to the emissions. So on the nitrous oxide side, again, I'm sure some of this has been mentioned, but we can mitigate nitrous oxide. It does start also with measurement. So once we start to understand the very dynamic process conditions and asset typologies that are leading to the production of nitrous oxide, which is basically being produced from the nitrogen which we're consuming and excreting, we can start to optimize our facilities. And the good news is that this is likely to prioritize asset health and enhance maintenance in a way that we haven't been so good at certainly in some countries. And there's plenty of abatement opportunities there, and then also some really innovative work going on, both in terms of of enhanced control, but also thinking more holistically about taking nitrogen out of the system. So there's multiple ways we can do that, perhaps on site through side stream treatments, but also we can actually think about the perhaps even the nitrogen that goes into the system to start with. We all eat more protein than we need to, whether that's chickpeas or cows. So there's lots that can be done then as well. But of course, that doesn't cover what's not in the race. And here we can see hot water use in homes is around 5.5 or 6% of national emissions. So water efficiency there, the way we're heating water in space is really key. You know, the water consumed in the products we buy and consumption, you know, we're not thinking about this. And of course, water use in agriculture, which is I think 70 or 80% of global water use, is really significant as well. And I guess as utilities and as practitioners in the water sector, we have links to every single citizen who uses water. And so there's a great opportunity to think about these conversations and maybe start the conversations around the way we're using water more, you know, more widely, and what, you know, what the water footprint is of our daily lives. So I think we've got a great opportunity as a sector to do that. And yeah, I guess then moving on and reflecting on some of the latest the discussion around heat recovery and wider energy recovery as well. Of course, if we change tracks and think beyond just mitigation of our water sector emissions, we really need to try to be thinking about our water resource recovery facilities as actual resource recovery facilities. And this is a quote from a recent technical workshop that was hosted along with the climate talks in Bonn, which I had the pleasure of being part of. And here we were able to get this kind of statement in the proceedings that we know wastewater contains many times the energy than we're currently expending treating it. And so we know there's unrealized potential and really need to be moving towards that more circular system. And that means we need to race well beyond water. Of course, water recovery and water reuse is really is a fantastic opportunity and also has carbon benefits. But if we go up this pyramid, which is adapted from some great Dutch work, we can recover all sorts of things. And really what's key here is thinking about the life cycle impact of this. This is just an example of a more progressive utility. So this is our Husvand, which we showcased in the recent Iowa guide. And here we can see scope 1, 2, and 3 emissions, and then we can see avoided emissions. And, you know, a key word there is potential avoided emissions. And we need to be really careful and really robust as practitioners when we're thinking about how we calculate and quantify these avoided emissions. But certainly we need to be showing them. You know, we shouldn't be netting them off in a way that's not really aligned with best science carbon accounting. We should be showing them as separate potential avoided emissions, and then really working hard with the supply chains and the catchments that we're part of to make sure that those are actually avoided emissions in terms of additionality and things. I think given time, I might skip across this one, but there's a great EU study which really highlights the need to apply life cycle carbon assessment. This is across all EU member states, and really highlights the relevance of those direct emissions of nitrous oxide, and then also factors in also the carbon benefit in this case of electricity production, renewable electricity production. But it's tools like life cycle assessment that are really key, and as practitioners we have a great opportunity to apply, and of course we need to go well beyond carbon and really think about the wider co-benefits. So we need to think about all our capitals, if you want to phrase it like this, in the solutions that we're in the solutions that we're discussing and really embracing as a sector. And I really like this diagram. This is also, we've adapted this in the Iowa guide, greenhouse gas guide we've just released, and it really highlights that we need to really make sure we don't have a simple carbon tunnel vision, and that we're really thinking about the wider implications of the sustainability transition, particularly things like overconsumption, like growth dependencies. You know, we have an economic system that's premised on infinite growth and a finite planet. Clearly this isn't workable, and really bringing in, you know, the equity and gender and diversity conversations that we know are absolutely critical. to finish, I guess I wanted to say we really must actually race back within planetary boundaries. So climate is one of those. But when we look at the others, nitrogen, phosphorus, water use, land system change, biodiversity and novel entities, water runs through all of these. So we have a fantastic opportunity to really mitigate as if it mattered. And with that, I just wanted to say thank you.
Thank you very much, Amanda, for your presentation. So it was the last one from the last keynote for today. I would please ask all the speakers to switch on their camera on, and we'll take some of the questions we had already within the Q&A before closing that webinar. We had actually one of the first one, Gis, was for you. I'm not sure I would read it for everyone. So and Mars has been front-runner in setting up N2O monitoring on a treatment plant level. Can you elaborate on a strategy how process emission will be reduced in the near future? Yeah, so that was the first question for you, Gers. And if someone else would like to also add something at the end from the speaker side, please feel free.
Yeah, so I didn't catch the entire question, but the last part was about us measuring on a plant level nitrous oxide emissions.
Yeah, can you elaborate on the strategy how process emission will be reduced in the near future?
Yeah, so we have a couple of pilots running where we are measuring nitrous oxide directly in our process. This is mainly to learn, so when do we actually get these emissions? It's mainly to evaluate if what we currently say that the emissions are actually corresponding to hard data, because most of the numbers are based on IPCC global numbers. So what we find is that it is particularly hard to measure actually your nitrous oxide emissions. That the first being said. And the reason that it's hard is that's very technical. Most of the sensors are not measuring in the right level of where the emissions are. So we have at many of our plants lower emissions than the not than the detection rate, but it's on the lower end of the detection rate of the sensors. So it's hard to measure accurately. That's the bad thing. The good thing is that it's actually quite low, much lower than we expect from the IPCC standards numbers for these emissions. But it differs also from plant to plant and from season to season. So at some points and at some plants, mainly the ones that are highly loaded, we see high emissions. But on the plants that are, let's say, lower loaded and operating quite stable and well, we see very low emissions. So that's, I think, a good thing. And we will start focusing for our emissions reductions on the highly loaded plants, and see if we can get maybe expand the plants to get to lower loadings, because that will probably be one of the first things to lower the nitrous oxide emission.
Thank you for the answer, I guess. If someone wants to add something, please let me know. No, otherwise I thought that some of you already provided with answers directly using the Q&A tool. So I think, Daniel, I would come to you. I know you provided a short answer. Maybe you can just develop on the question So the comment was from Christian. Hi Daniel, excellent presentation on future options toward net zeros. Indeed, I agree that the ongoing decarbonization of grid electricity shift to option of water utilities for climate change from self-production of electricity towards providing biomethane and green heat to other sectors. However, we still see in Germany that high electricity price and still relatively low revenue for biomethane and or green heat are hindering this transition because it is just economically not feasible. How do you solve this in Zurich? I know you provided a reply in a Q&A. I just want to jump on it because it's also a discussion we had at IWA. Thank you.
Yes, I know this is this is one of the hardest part. You have the economical feasibility or how get you the money, and I answered it short. The first is to say wastewater treatment and all of our parts are not economical, or we don't produce any money from out of there. So why we do have to produce it in this part? So we convinced the government to give a little bit of the fee. It's not a lot to invest in those projects we started in the biogas project. We also, and this is, I think this was the key turning point, was we cooperated with the energy supplier. So it's not us who is like building the heat, this heat network. It's the energy provider because he has the household, he has the energy. You need about a third of electricity to get out heat from the wastewater. He has the network in the house, so he has all the stuff. So for him, it was a business field, and it's still a business field for the energy provider. It's on the other hand, it was a business field in the biogas for the gas supplier in the town. It's like, hey, people will use a little bit biogas, but it's biogas, and that was it. So don't be too narrow in your thinking. Don't think that you have to do it. Try to cooperate with the suppliers. That was one of the biggest things. So we are just giving the biogas, we're just giving the heat, and they do all the rest. And for them, it's very, very interesting to be in this part. That's now the longer answer.
Thank you very much for that longer answer, and hopefully from giving tips if anyone else has to convince the local city hall for doing the same project and to have that global vision. I'm just quickly looking back and forth on the Q&A. I think you also have access to it if you really just want to pick one up. Please feel free. I'm not sure if I think Alexis, you had something about more your presentation and the urban wastewater treatment directive. I'm not sure if you want to develop it or not really.
I have put the details of
Yeah.
a quick high-level summary in the chat. If there are more questions, feel free to post it in. Note that again, it's at a proposal level. These are not final decision from the directive, so that needs to be clear for the audience.
Yeah, something I also just picked up that question or that topic just because I wanted to mention that as you just mentioned, it's still at a negotiation phase. It's still not sure, and we are following it here with some of you, can say with Xylem as well. And we hope that we can say more when the final text is adopted. Then we had also, I think would be either for you, Slavko, but I think Alexia as well, because I think Xylem offered. If you have experience in model of digital twin of a wastewater treatment plant, and if yes, if you had some outcome or feedback to give about this. Thank you.
So yes, definitely, Arthur, and thank you. I think Dr. Anna has posed that question as well. So yes, digital twins are playing an important role on digitalization of the wastewater treatment plants. In order to optimize the processes, we would like to build a digital twin, starting from zero, basically connecting the existing data, such as asset data, BIM models, building information models in 3D, 2D, 3D. And finally, the data, if we are measuring BOD, nitrogen, sulfur, phosphate level, etc. So bringing this data live in a digital twin will give the performance, how the digital twin wastewater treatment plant is performing now, and also simulating certain scenario. If I change a little bit certain settings in the operational plant, how it will affect, for example, the process treatment, secondary or tertiary treatment as well. So yes, digital twins are being on the rise in order to improve efficiency of the wastewater treatment plant. And Bentley and obviously Xylem have technologies to do that. So if you want more information, we can share some case studies with you. Please reach out.
Thank you. Okay, and then we had the questions. I think it's a bit for who would like to try to answer that one. Was how important are decentralized treatment units in this conversation, and what role can they play in a waste to zero? For example, how smart is it to recover nutrients at a decentralized manner, 200, 250 people equivalents? I'm not sure if one of you would like to provide an answer. I would not be capable of.
I have quite an opinion on it.
Yeah.
I don't know if that's the right way to start an answer.
Please.
We at AMA's have a highly centralized wastewater treatment infrastructure, and I think if you consider all the ambitions on climate, on extra micropollutants removal, on whatever you want, you need to make large investments. We see it also in Zurich. They can do all these additional things because they have a large centralized plant, I think. Yes. You need a certain size to do certain additional things. So I think in view of the climate ambitions, decentralized from a technical point of view is not optimal. There can be all other types of arguments that make you want to choose eventually for a decentralized system in certain configurations. But I think from a technical point of view, operation, extra investments, financial, centralized is a smarter way to go, because you can do all sorts of additional techniques in nitrogen recovery, heat recovery, biogas production, etc., etc. I like to hear if anyone has another opinion that would be for a nice discussion, I think.
I think that from a I think there's the existing legacy asset that we have, and I totally agree with I think what you say there. But when we think about the houses that we need for the future, we're still building houses. I mean, we're retrofitting houses. Switzerland is a very nice example. I was just at the urine separating toilets in Dubendorf not that long ago, and thinking about the local, the way we locally reuse nutrients, the local stormwater separation we require, the role, the impact of, for example, removing nitrogen at source actually has multiple benefits downstream, including nitrous oxide, including corrosion in sewers, and perhaps supports the agricultural transition we need in some scales at some, in some instances. So I do think that it's, for me, it's, I don't think it's not either or, but it's how can we think holistically and I think the new housing that we're building, there's no way we should be building that in the same way that we currently are when it comes to water and potentially nutrient management as well. So I do think there's opportunities there, and I guess when we think about all the low and middle income countries and systems without centralized treatment, you know, there has to be a better way, because the way that we are currently progressing is nowhere near getting us close enough. So whilst I agree with what you say, I think that we shouldn't, it's not an either or question, it's a and how, you know, how can we, what else? Yeah, we need so much more. Sorry, that was my opinion.
Thank you very much, Amanda. Yeah, Daniel?
Sorry, I completely agree with you too. If you look at it, if we have about 700 wastewater treatment plants in Switzerland, and I think about 100 to 150 are below 500 people equivalent. So we already have those plants, those small plants, and they are more cost intensive than a big plant. That's one part. The other part is, yes, you know, you don't use a big drainage, so it's okay, and it's good for the indirect emissions, but the use of the energy in the wastewater, you have in the day like peaks. You can't manage them if you want to use it. If you use it like Amanda said before, as take out the nutrients, bring it directly to the agriculture site, then it's okay. But I think it's not the way we should go into cities, into and the way there, because there it will be a complete transport. A complete change of the transport. If I would take the wastewater from Zurich into my plant, I had every 5 seconds a big lorry on my in my path, and this is just the water. If you need the nutrients, it's a complete. I don't know how we manage this in the scene of fossil free in a fossil free future.
Thank you very much, Daniel. Does someone wish to add something? Otherwise, we had 1 or 2 more questions. We started a bit late. I'm taking the liberty to take an extra 5 to 8 minutes. Maybe we had someone asking all of you, according to your various experience, what has been the cost of the utility for transition? Can it be self-financed? Was it subsidized, or did it require water price increase? And if yes, by how much? Thank you. Or how do you see that all the technologies that were presented that come, of course, as a cost could be then implemented?
So it's an interesting question, working, let's say, in the EU countries, but also working globally as a technology vendor. We see that the budget is really, at the end of the day, the driving factor for this type of innovation and embracing new technologies. So one of the things that some of the companies develop, for example, in the Middle East, but also in Europe, is 2% of the budget, which is coming from the service water tariffs, basically, should be put for innovation and proof of value and proof of concept projects, like implementing digital twins, decentralized treatment facilities, new technologies pilot, for example, for desal of water, but also for wastewater. So we see that there is a possibility, without increasing the tariffs, which are pretty sensitive topic of discussion politically as well. So putting 2%, let's say, of the revenue of the company for this type of early adopters version of technologies is the way to go, in my opinion. And of course, technology vendors can help there by providing technologies as a trial or a proof of value technology in order to accelerate those developments. And budget can be made. I think also European Union is subsidizing a lot at this point in time for the water utilities who are putting forward proposals in terms of a race to net zero. Typical examples could be subsidy for electric cars, green cars. Let's say electric cars for the operational stuff of the water utility can get subsidized. Second is subsidized to change all of the lamps in the buildings, instead of having a bulb lamps, to put the LED lamps as well. Subsidy, for example, to put solar panels on the roofs in order to produce electricity for the wastewater treatment plant. So there are a couple of subsidy directions, depends on the country, but also European level as well. They have a subsidy levels in order to accelerate this embracement of new technologies.
Thank you, Slavko.
I'd like to maybe add
yeah.
a perspective I won't be able to say how much and how. However, what's aligned with what Slavko said is the transformation is not immediate and requires thinking overall. We know that for water and wastewater services, the overall turnover, I mean, the overall sales cycles or transformation cycle is a minimum 10 years. If we want to apply the transformations that Gace was presenting, we're talking about a cycle of minimum, what, 20 years, Gace, if we look at the overall infrastructure that needs to be transformed. So my point here is first, plan ahead. It's a question of strategy. It's not something that we can do immediately. So the planning is very important. And second, aligned with what Slavko said, look across or look outside the box, look outside the common technologies and infrastructure that we've been investing for the last 50 years, because we know that we've been doing it wrong. We've been depolluting water to pollute atmosphere. And that is what the opportunity that we have today is to think strategically at using wastewater as a center of resource recovery. And so on that perspective, what needs to be done? We have nature-based solutions, we have digital solutions to start with, and then what is the big massive transformation that is needed for the recovery part afterwards? So that is maybe a perspective to add on.
Thank you very much, Alexi, I guess.
If I might add, because I think what Slavko said about other incentives is totally true. We see this with basically all our energy production. We want to be energy neutral. We have energy production, biogas, solar panels, windmills, whatever, wind turbines, whatever. These have all incentive schemes on a national level that we can use, and we can present to our board a perfectly profitable business case for any investment that they need to make. So this is, I think, an easy part. For the climate emissions, greenhouse gas emission reduction, it's a bit more difficult. But the way to go, at least for us so far, and it hasn't been mentioned yet, is the application of CO2 or greenhouse gas shadow cost. And you can put whatever number on some CO2 emissions or equivalent emissions. We started out with, I don't know, €5 per ton a couple of years ago. Currently, I think it's quite common to use something between 100 and 140 or 50. But there is also already municipalities in the Netherlands that use a CO2 shadow cost of by heart, I think €875 per ton. Not sure what report was behind it, but there was some calculation on what the real costs of CO2 emissions are on a society level. And if you apply those in your proposals or in your business cases, it can be very easy actually to present business cases that make sense on these ambitions to become climate neutral.
Yeah, I would just agree with that. In the UK as well, there's a number of utilities using a shadow cost of carbon. And I think that, there's a very nice social cost of carbon document actually that was produced in the US, which gives a social cost of carbon dioxide and methane and nitrous oxide. And some discussion about discounting and what we shouldn't be doing. So I think, yeah, this makes a lot of sense. I mean, we could also stop, be advocates for stopping the subsidies of the things that are actively working against us, like all of the money that goes into fossil fuels, which you could say, well, that's not really our job or in water, but the reality is that this has to change. So we need to play a role in this. We're all people, we're all citizens. So I think the combination of these things would be incredibly impactful. And of course, we can find money for wars and pandemics. So if we actually wanted to find the money as governments to solve the greatest crisis to humanity that has ever existed, we could. But I guess we need to raise our voices for this as well. Yeah.
Thank you very much, everyone. I think also due to time, we might stop. We will stop here, not we might. I will just quickly share my screen. But first of all, I would like to thank everyone, especially our speakers, for all your presentation and taking the time today to join us to prepare for that webinar, and as well to take all of the answers today, and as well as the participants for all the comments either in the chat or during the questions. Then I would like as well to thank once again our sponsors, Bentley and Xylem, for making that event possible, and especially possible free of charge for the participants. Everyone will receive the presentation that were done today, and a link to the video of the recording of today's webinar will be available next week on the EWA channel. And if you would like to note, we have some of the upcoming EWA events. We plan an online webinar on the digitization in water sectors on the 6th of December. We will be with the International Water Association Congress and Exhibition in Kigali, and next year in Pula, Croatia, and in Munich. You can also follow us on social medias and as well as our newsletter. Once again, thank you everyone. And when the call will end, we would really appreciate if you can all take the 2 minutes to provide feedbacks. So once again, thank you very much everyone for the lively discussion and conversation. Was everything interesting? I wanted to make a conclusion, but with the last one, you all stole all my talking points. So thank you very much once again.
Thank you.
Thank you.
Bye-bye.
Bye.